You spend hours writing code. It runs perfectly on your laptop, and you proudly send it to a teammate. But the moment they try to run it, the whole thing crashes. It is the classic works on my machine problem. This happens because your computer and your teammate's computer are secretly very different. You might be running a Mac while they use Windows, or maybe you have a newer version of a software tool installed while their machine is still using an older one. Docker was built to handle this by isolating your application from the computer it happens to be running on. By removing the host computer's unique quirks from the equation, your code experiences the same environment every single time you start it up. To understand how this works, think about a physical video game disc. When you put that disc into a console, it plays the same game the same way, no matter whose house you're visiting. In the Docker world, that sealed game disc is called a Docker image. It is a packaged, read-only blueprint that holds the code and the tools your app needs to function. This diagram shows the difference between owning the game and actually playing it. On the left is our static game disk, the image. On the right is the actual gameplay. When you take an image and tell your computer to run it, it becomes an active Docker container. Notice how the image itself never changes. It acts as a single protected source of truth, spawning as many live active containers as you need. Because the static instructions are locked safely inside the image, you get predictable results. If that blueprint runs on your laptop, it will run the same way on a server across the world. So, what is actually inside that sealed Docker image? Let's crack it open and look at the structure. This 3D cross-section shows an image's anatomy. At the bottom is a stripped-down operating system, followed by the runtime engine that reads your code. Next, the final pieces drop in: third-party tools, your code, and configuration variables. Finally, the cube seals shut. With all 5 of those layers packed together, the application brings its own environment with it. It doesn't need to rely on your laptop's specific setup. To build this sealed cube, you write a set of simple instructions called a Dockerfile. You can think of it as a step-by-step recipe card. This image shows a standard Docker file. It flows logically from top to bottom. From selects your base operating system, copy moves your code inside, and run installs your third-party tools. Every single line in that Docker file creates a permanent, distinct layer in the final image. This layered design makes things much faster. If you change a single line of code, Docker reuses the layers it has already finished and only rebuilds the specific part that was altered. This architecture means you aren't stuck waiting for the computer to redo work already done, which makes building and updating your app much more efficient. Once you've built this image, where does it actually live? You send it to an image registry, like Docker Hub. A registry functions like an app store for developers. You can visit this store to pull down official images for common tools like databases, or you can push up your own custom images for your team to use. Because the registry is central, a teammate can download your exact image and be up and running in a matter of seconds. To get the most out of this system, you want to keep your images lean. Smaller images are much faster to build and download. You can trim the fat by using a .dockerignore file. It acts like a bouncer, keeping unnecessary items, like your personal local testing folders, out of the final build. You should also give your image a specific version label, which developers call a tag. Think of it like a label on a jar. Avoid using a label called latest, because what is latest today will change tomorrow, and that can lead to unexpected results when you run it later. By following those steps, you create a layered blueprint containing your code, your tools, and your operating system, all sealed together. Docker images shift development from fixing setup errors to shipping software that runs exactly the same way in production as it does on your own